Hey guys, what's up? This is Steve. Today let's go through LeetCode problem 1138, alphabet board path. Let's take a look at the problem first. On the alphabet board, we start at position 0, 0, meaning left, top left, corresponding to character board 0, 0, which means here. Here, the board is a fixed board. It's a very limited small set of characters. And the size of this board is fixed. It's given. It's kind of 5 by 5, but it's 5 by 5 plus 1 because it contains all of the lowercase English letters, which is 26. So 25 plus 1. Z is here, as shown in the diagram below here. We make the following moves. And U stands for up. We move one position up one row if the position still exists on the board. D is down. L is left. R is right. Exclamation mark. This means we find the character that we want to insert. We just append an exclamation mark to this string builder, which means we have found this character. Alright, so here the only positions that exist on the board are positions with letters on them, which means it's every single one of these 26 characters. That means the position exists based on the definition of the problem. Return a sequence of moves that makes our answer equal to target. This is a string or a word that was given in the parameter. In the minimum number of moves, you may return any path that does so. For example, here, example 1. First, the target is leet, L-E-E-T. Remember, we start from the top left, which is here, A, right? So the first letter we want to find is L. Okay, L. L is here. We can go this way, right, and then down, down. Or we can go down, down, and then right. Right? So either one of these two moves are correct. So let's take a look here. So it's going this way. Down, down, and right. Down, down, and right. So leet. Next is E. E is here. You can go right, 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 up, up. Or you can go up, up, and then right, right, right. Either way it works, right? That's how it works. Then once you find L, you do an exclamation mark. Once you find E, you do an exclamation mark. The reason why there are two exclamation marks here is because there's a consecutive E here, right? Double E, L-E-E-T, LeetCode, leet. Double E here, so that's why we don't need to move around to find the second word, to find the second character, because it's the character itself, it's the previous character, which is E. So we just append a second exclamation mark here. And then we find T. Where is T? From the E's perspective. So T is here, down, down, down. We just go down 3 times, down, 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 then exclamation mark. Then that marks the end of this entire moves that we need to take to form the word, to form the target leet based on the positions of this board. So that's how it works. Then the second example code, it's very similar, right? You can do either go to the right first or go to down first. Either way, you just need to find the correct position of the next character on the board before you can move, right? This is a very straightforward problem. One corner case that we need to handle is that when we move around the board, we want to make sure that the board does exist. The position that we're about to move into does exist on the board. That's one case that, or one condition that we need to take into consideration before we can get our code accepted, I assume. That should be the case. Other than that, we can just traverse through every single character of this given target from the top left corner, which is 0, 0. We try to find every single position, go by row index and column index. So as long as we find that, we'll just append an exclamation mark to it. That's it. All right. So when it comes to actual implementation, what we can do is that we can initialize a hash map. We can put every single character as the key of the map and put the actual coordinates. For example, we can use a 2D array. 0, 0 is just the coordinate for the character A, and 0, 1 is the coordinate for letter B. We can put that as the value of the hash map so that we can easily retrieve the coordinates of every single character that we're about to move to. And then we know the current position. We can just go by row and go by column. And once we get there, we'll just append an exclamation mark to the string builder. In the end, once we have finished, we have found all of the characters on this board, we can just return string builder dot string, right? That's the entire idea. Now, if it's clear, that's perfect. If it's still not super clear about how we can approach this problem, let me put the idea into actual code, and then hopefully things will be a lot clearer. All right, let me just move things around a little bit. Okay, now let's start writing the actual code. So first, let's build a hash map which contains the ladder to coordinates mapping, which will give us a very very easy access to the coordinates of the next character that we're going to move into. So let's put character, and the value of this is going to be a 2D array. Map. I'll write another small function called init map. This is just we don't need to take in any parameters. And the output of this, because it's an lowercase English letters only on the board, so we only need to put 26 characters in there. Then output is character int init map. That's it. So now let's quickly implement this method. So first let's initialize a map new hash map. In the end, we'll return map. We'll have a variable we'll call it row, another variable we'll call it column, and then another one which indicates the total number of characters that we have gone through. It's going to be 26. So let's start with 0. Every lowercase English letters is all of the letters that we care about. So let's just go through this. For char C, we'll start from A, and we'll just increment this until it's smaller than or equal to Z. We're good. And also we want to increment number. This is the number that we'll keep track of. Well, this is the number that's going to help us keep track of how many characters that we have constructed already. So the first one is going to be 0, 0, right? Which is the coordinates for the first letter, which is A. Now we want to, instead of just a number A, B, C, D, instead of 0, 1, 2, 3, we want to put them into row and column, right? We want to map them to a two-dimensional map. So that's why we have row and column. So a good way to map a 1D index to a 2D indices is we can use number. Then so here is 5, right? Because this is a 5. We have a total of 5 columns here. So we want to divide it by 5. We do a round division. In computer science or in Java, this language, this is round division. So for example, if number at this point is 6, 6 divided by 5, that's going to give us 1, which is correct, all right? So the F, the row column index, is going to be 1, right? And then we have column, in which case we can use number. We do a modular of this 5, in which case is still correct. For example, number is 6. 6 modular 5 is 1, which is still correct, right? 1 and 1. 6, is that correct? 6 is the correct number of the letter G, beginning from 0. 0, 1, 2, 3, 4, 5, 6. So 6 equals to G. G maps to the number of 6. And how do we know the 2D index of the letter G? We know is 1 and 1, right? So here is 1. The second row, which is 0 and 1. The second column is 0 and 1. So the G column is 1, 1. So we got it by doing a division of 5 and do a modular of 5 from the number. So that's going to give us the correct row and column. And then we just add it into the map. We put this into the map. So here is the column, the character, and then here we put row and column. This is to help us to build up this map, right? All right, now this map has been finished initializing. So now let's go through this target. We need a stream builder. I'll call it stream builder. Next, what we want to do is we want to just go through this target to char array and here. So we know the starting position. We'll just call it a current position, which is the starting position, which is 0, 0. We initialize a 2D array, which stands for x and y coordinates. And if we don't put anything there, it's going to be initialized to be 0, 0, which is correct, all right? As the problem states, it's going to start at position 0, 0. All right. And then we'll just move this one to whichever point that we need. So we'll move to, I'll have another helper function called this, move to destination. So we'll take current position and then C and SB, which is the string builder. And in the end, we'll just return string builder to string. All right. So now let's implement this function. Private, we don't need to return anything. So here, current position, and char C, and string builder SB. All right. Now let's implement this function. This function is basically we're standing right now at current position, and we know the target is C. What do we need to do? What kind of moves do we need to take? Go right, down, or go above, left? These are how we are going to find all of the moves that we need. Basically, we need to move around on the board to find the target character. Or I think we can call it, this one is destination, so that it's easier to understand. Okay, to make things even more clear, let's just have 4 more variables to break things apart. I'll call it current row, which is current position 1, and then another one, current column, which is current position 1, and another one, destination row, which is okay, and then we need a destination. Oh, instead of this should give us index instead of this char, which is wrong, which should not be char. That's the whole purpose that we have initialized this map, is to give us this coordinates, the coordinates of the target character that we are moving into. All right, so this should be destination. This is correct. All right, now this should be dest. Now we have dest column, which is here. Now our task is to move the current row and current column to the destination row and destination column. Basically, we move up, right, left, and down, right? So all of these are the 4 possible options. Basically, we're going to use a while loop. Then what's the exit condition or the break condition of the while loop? That is, as long as current row not equals to destination row, or current column not equals to destination column. Only when both of these 2 coordinates are the same, that means we have found this target character's position right on the board. If either one of them is not true, that means we still need to keep moving around. There should be a total of 4 different cases. The first one is basically we're going to compare which one is smaller or which one is larger. If, like say, for example, if current row is smaller than destination row, what that means is current row is here and destination is here. We'll just keep moving down, right? All right. What we'll do is while current row is smaller than destination row, what we will do is that we will keep appending down, right? Append down, and we'll add current row. We'll keep incrementing current row so that we know current row is going down. Only when current row equals to destination row, then we need to break out, right? That means we have reached this point. But here, this is one of the corner cases. This is the, I think, could be the only corner case here, which is because, say, for example, if the column is at index 0, it's totally fine. You can move all the way down to 0, right? But if the column is like any one of these 4 columns, which means if you move here, destination is here, but you cannot really move the current column down here because there's nothing on the board here, right? Which means if your target is Z, but currently your current row is somewhere here, you can move all the way down here, but you cannot go down here and then move towards the left. You have to stop here and move towards the left first before you go down again. Okay, so this is the corner case that we need to take into consideration. So let me put another case here that we need to break out. Not actually here. The case that we need to put into is if column. So if current column not equal to 0 and current row equals to 4, 0, 1, 2, 3, 4. If both of these two conditions are true, then we need to break out, right? That means that just means I'm just basically translating what I just described in words into the actual code, which is this case. Current column is not equal to 0, which means it's one of these 4 columns, right? 1, 2, 3, 4. One of these 4 columns. And current row is already at 4, 0, 1, 2, 3, 4. It's already in this row. Then we need to break out. We cannot go down here, right? We just break out. All right. This is the first case. Now we have taken care of that corner case. What we need to do after we break out of this while loop, what we want to do is that we want to update this current path position. This first element, which is the row, to be the current row, right? We need to update this current position. Okay, this is the first case. Second case is that we want to, if the current row, all right, let me just copy this. If current row is greater than destination row, what is that case? That means destination is G and current row is at V, this level. We want to go up, right? Okay, now let me just it's very similar structure, but we have to implement this. While current row is greater than destination row, what we will do is that we'll append up. We'll keep going up, and current row will keep decrementing current row, right? So in this case, there's no such a corner case, right? If we're right now we're here, we can keep going up. If we're in here, any one of these 4 columns, we can still go all the way up. Here, this is fine. So after it breaks out of this while loop, we'll also update this current positions row, which is current row, right? So now we have taken care of the row is not at the target position in both cases, right? Now we'll take care of the column. It's very similar. So current column is smaller than destination column. What we will do is that while this is the case, copy this. While this is the case, we'll just keep append. Current column is smaller than destination. We'll keep moving to the right, right? So we'll append it to the right, and current column plus plus. We'll keep incrementing this. And when it breaks out of this while loop, we'll just current position. This is 1, because 1 is the column index. Current column. All right. And then the last case, which is if current column is greater than destination column. Let me copy this one as well. While this is the case, what this means, the current column is on the right and the destination column is on the left. So we'll keep moving towards the left, right? So we'll keep moving towards the left, and we'll keep decrementing current column. When it breaks out of this while loop, current position 1 is going to be current column. All right. This is all of the 4 possible cases, possible branches, that possible scenarios that the current positions could end up with the target destinations, right? Once this one breaks out, which means this while loop gets broken out, that means, where am I? I am here. Okay, so that means both of these 2 conditions are met, which means we found the position. So at that point, what we will do is that, I think it's here, right? So at this point, we found the character that we are looking for is the target, is the destination, what we will do is that we'll append the exclamation mark into the string builder, right? Then we can just return. This is the void function. All right, that's it. I hope this makes sense. It says you can return any one of the valid answers, so you can move up first or down first. It doesn't matter. It says any one of the valid answer could work. You may return any path that does so. All right, now let's try to hit run code to see if there is any compile errors. Judging, cool, accepted. Now let me hit submit. Wow, accepted. That's cool. 47 and 81. Let me hit submit again. Let's see if there's any difference. 47, 57, and almost no difference. All right, but here's the code. Here's the idea that how we can implement this. I hope this makes sense. We can simply use a hash map to hold all of the coordinates of every single character on the board, and then we'll just keep moving around on the board. And while we're moving around, we want to make sure that the next position that we're about to move into is still within the board. I think the only one corner case that we need to take into consideration is this case, which means if we are moving down, we want to make sure that if we are not in the first column, we cannot move down to the 6th or the 7th row, because there's only the first column has the last row, has the last character, which is Z. All right, I hope this video does help people understand the algorithm or the idea to solve this problem, or how we can apply hash map to help solve different problems. If this is the case, please do me a favor and gently tap the like button. That's going to help a lot with the YouTube algorithm. I really appreciate it. And don't forget to subscribe to my channel, as I have accumulated quite a lot of different videos for talking about LeetCode problems, data structures, algorithms, Amazon Web Services, cloud computing, anything tech related that I'm super passionate about. Feel free to check them out. Hopefully I'll just see you guys in just a few short seconds in my other videos. Thank you very much for watching. See you guys in the next one.